In science, we often deal with the extremely large and the extremely small. So if you're talking about astronomy and distances between planets, you can get numbers like this. Let's see, this is 1,000, million, billion, what is that, 14 trillion light years? And we can put commas to separate the zeros into groups of 3, but it's still kind of confusing. And when you copy a number down like that, it's easy to get it wrong. Your calculator might not have enough display places in its memory to hold the numbers, and so it's cumbersome. It's cumbersome and it's difficult. So we use scientific notation. When we take a number and write it in scientific notation, there are two parts. Here's an example of a number in scientific notation, 1.2 times 10 to the minus 10. So there's a decimal part. So we take the number and we move the decimal point so that we have a number that's between 1 and 10. And then there's an exponential part, which is 10 raised to an exponent. Okay, so this is 10 raised to the negative 10th power. If the exponent is positive, it means that you've got a 1 multiplied by 10 that many times. So 10 to the 0 means 1 multiplied by 10 0 times, so that's 1. 10 to the first power is 1 times 10 once, that's 10. 10 to the second power is 1 times 10 twice. 10 to the third, 1 times 10 3 times. Another way, the way I prefer to think about it, is the exponent tells us how many zeros to put after the 1. So here, 10 to the third, that's a 1 with 3 zeros after it. That's 1,000. 10 to the 0 is a 1 with 0 zeros. It's just 1. So those are positive exponents. If the exponent is negative, that means you've got 1 divided by 10. Instead of multiplying, we're dividing. So 10 to the minus 1 means 1 divided by 10, or 0.1. 10 to the minus 2, 1 divided by 10, 2 times. 10 to the minus 3, etc. Any questions? They did teach you this at some point in your previous academic career as well. But like many things, if you don't use it all the time, then you lose it, right? You forget about it. So how do you express a number in scientific notation? So these are the steps. You move the decimal point so that you get a number between 1 and 10. And then you write that result multiplied by 10 raised to the number of places you move the decimal point. This explanation here is slightly different than your textbook. This is how I think about it. Either method will get you the same result. If the number that you're dealing with is a big number, bigger than 1, the exponent's positive. If the number is small, less than 1, the exponent is negative. So big positive exponent, the way I think about this, if I get a large paycheck, do I have positive or negative feelings about that? Positive. I have positive feelings about a large paycheck. What if my paycheck's really small? Negative feelings, okay? So large number, positive exponent. So 2 examples here. So this number, 5,983, can be expressed in scientific notation. What we're going to do is we're going to move the decimal point so that we make the number between 1 and 10. So the decimal point is always going to go after the first non-zero digit. So we put the decimal point there, and then we write times 10 to the something, and the something is how many places did we move the decimal point? The decimal point originally would have been here after the 3. It wasn't written, but it's understood. So we count over 1, 2, 3. We moved it 3 places. So the exponent is 3, and then we look at the size of this number to decide, should that be a positive 3 or a negative 3? Well, 5,983 is a large number, and so it's a positive number because I feel positive about large paychecks. So here's another number, 0.00034. So again, we're going to write this as a number between 1 and 10, so 3.4. Put the decimal point after the first non-zero digit. So 3.4 times 10 to the something. We go over here and count. We would 1, 2, 3, 4. The decimal point has been moved 4 places. So the exponent's 4. Positive or negative, we look and see, is this number larger than 1 or smaller than 1? It's small. I feel negative about small paychecks, so this exponent is negative. So let's do an example here. The total U.S. national debt in 2016 was approximately that number. Right? That's a really big number. Express this number in scientific notation. So we're going to write it as a number between 1 and 10. So here's our number, 18416, and we'll just leave off all those zeros at the end. To make this a number between 1 and 10, I need to put the decimal point after the first non-zero digit. So 1.8416. Okay? And times 10 raised to a power. So now I'm going to see, well, the decimal point was originally right here, and now it's over here. How many places did I have to move it? So 3, 6, 9, 12, 13. I moved it 13 places. So this is 10 to the 13th, and then I decide on the sign. Is that a big number? It's a heck of a big number. So it's a positive exponent. So we can express that in scientific notation, 1.8416 times 10 to the 13th. Any questions? Let's take a number that's small. Express this number in scientific notation. Again, we're going to write it as a number between 1 and 10. So all of those zeros in the beginning, we don't need those. So we've got 3 and 8, and I'm going to put the decimal point after the 3. The decimal point always goes after the first non-zero digit. So I've got 3.8 times 10 to the something. So moving the decimal point, 1, 2, 3, 4, 5. I moved it 5 places, so the exponent is 5. And then I decide, is this a small number or a big number? It's a small number. I have negative feelings about small paychecks. This is a negative exponent. Any questions?